So we're going to continue to look at how sound waves work, in particular how we interpret sound waves that our ears pick up. But first off, how do you make a sound wave? Well, as we saw in the previous topic, you want to vibrate the air backwards and forwards to start that compression wave moving along. Of course, I could wave my hand backwards and forwards. That actually does start a sound wave, but not one that our ears can hear. A loudspeaker, which might do a better job, for example, is just a specially shaped piece of cardboard or metal that's being vibrated backwards and forwards very rapidly that starts off that compression wave. And it does so in a range of frequencies or wavelengths that our ears are sensitive to. When we hear a sound, what's really happening is the internal structure of our ear is feeling the vibration from that compression wave in the air. It turns out that our ears and our brains can only hear a certain range of frequencies of sound waves. Let's have a bit of a look right now at what that range might be. So I'm going to play some notes and show you that the frequency of the wave we interpret as the pitch or the note that's being played. So we'll start off now by playing a tone kind of in the middle range somewhere. And you can hear that tone there. That actually corresponds, as we see here, to somewhere between 400 and 500 hertz. Now if we make that a bit lower in frequency, we lower that down, we start to hear a much lower tone. And in fact, below around 10 to 20 hertz, our ears don't work very well at all. We can make that go up to a much higher number of cycles per second there, a higher frequency, again a higher pitch. I can take that up to an even higher sound. This is a 1 kilohertz note you're hearing now, and that's quite a high note. We can take that up a little bit higher, and we can go even higher again. Now we're hearing about 10 kilohertz. That's a bit painful. I won't make you suffer through that for too long. At those very high ends, it can be quite intense in our ears, and we start to lose our ability to hear above about 20 or so thousand hertz, 20 kilohertz. And in fact, as we get older, that higher end starts to deteriorate a bit, and we come down a little bit in range. And of course, as you may know, that's just our ears. Different types of ears, different animals, different creatures can hear in different ranges. But it still has that association where the frequency or the wavelength is telling us about the pitch of the note. Another aspect of sound waves that we're quite familiar with is the volume or loudness of the sound. Our ears turn out to be amazing instruments at detecting differences in volume or loudness. This actually corresponds in the sound wave to the level of power per area, which we call the intensity of the wave. A very intense wave, a large amount of power per unit area, is a very loud sound. Now the range at which our ears can detect is very large indeed. So the minimum that we can usually detect is something in the range of 10 to the power of minus 12 watts per square metre. Kind of like a really low level whisper. And then we can detect up to very large multiples of that. In fact, 10 to the 12 times as much as that, up to about 1 watt per square metre. When it starts to become very painful and permanent damage is certainly possible. In fact, damage to our ear is possible at even lower sound levels for prolonged exposure. So we need to treat our ears quite carefully. This is such a large range that in fact we don't typically talk about the intensity in terms of power per unit area. We tend to use a logarithmic scale where we're increasing by powers of 10 because it covers a much wider range. And for that we use a unit we call the decibel. The decibel is defined, as you can see here, as the logarithm of the intensity that we're feeling divided by the minimum possible intensity, that 10 to the power of minus 12 watts per square metre. And then we multiply that by a factor of 10. So that would mean, for example, for a whisper might have a sound intensity here of maybe something like 1 dB, 1 decibel, as we would say. Whereas maybe a loud concert you might go to, where there's some amplified music, that might have a sound intensity there of maybe, say, 80 to 90 decibels. That would be quite loud, and again, you wouldn't want to be hearing that for hours and hours on end. Hearing damage might occur. And of course, that level of pain and almost certain damage to your ear will occur at a much higher level. It might not seem like much of a higher level, something here around 120 decibels. But remember, this is a logarithmic scale. We're going up by factors of 10. Not just by going up by a difference of 10, but by a multiple of 10. So now we've finished looking at some of the aspects of sound waves and how our ears respond to them. What we're going to do in the next topic is start to look at some of the wave properties that these sound waves might have, in particular how they might interfere with each other.